Okay, so next up, we're taking our straight line work a little bit further by combining it with the work that we've done on gradient. And we're going to look at lines that take the form y equals ax plus b. Okay, so we're looking at the equations of these different lines, and these ones are just slightly different to the ones we were looking at initially because they combine something in terms of gradient and something else which we're going to try and uncover as well. Okay, so we're going to start with something similar to what we were doing before. We're going to start with a table of values, okay, and we have to calculate them using the equation that we're given in each question. Okay, so there is a line that exists, okay, and we can draw it on a set of axes. And that line has an equation y equals 2x plus 1, okay? And what we basically want to do is we want to draw a table of results like we did before, find out what those results are, change them into coordinates, and then plot them on a set of axes, okay? So in the same way we did before, we're basically going to take these different x values, and that's all this is, okay? We've got 5 different x values here. We've got 0, 1, 2, 3, and 4, and we're going to take them and we're going to put them into our equation, y equals 2x plus 1, okay? So what it means is y will equal 2 times by our x value, and then we add on 1. So given our x values, our 5 x values along the top, for the first one is going to be y equal to 2 times by 0 and then add on 1, okay? 2 times by 0 is just 0, and when we add 1, we get an answer of 1, okay? So similarly for the second one, it's going to be this time, it's going to be y equals 2 times by 1 and then add on 1. 2 times by 1 is 2. When we add on a 1, we get an answer of 3. And then we can keep going. Right, what you'll find, hopefully, is that you'll find a wee pattern emerging, okay? And that's where it links back to what we were doing before all of this in terms of sequences, okay? But just to be sure, it's worth going through and checking all these through the equation. So this one's 6 plus 1, which will equal 7. And then the last one will equal 2 times by 4, and then add on 1. 2 times by 4 is 8. Add on 1 is 9, okay? So we've got these 5 different values for y, given our 5 different values of x, okay? And what that means is we have a coordinate. If you think about a coordinate every single time is just an x value and then a y value, and that's what we're changing these into, okay? Our x value for the first one is 0, and our y value is 1. Our x value for the second one is 1, and our y value is 3. For the third one, we've got 2, 5. For the fourth one, we've got 3, 7, and for the fifth one, we've got 4, 9. What we can do with these 5 different values is we can take them and we can plot them on a set of axes. So the first thing I want you to do when you get to this stage is we'll look at your coordinates, okay? None of these are negative, so we don't need to worry about the negative kind of quadrants, as we call them, in a set of axes. All we need to do with these is worry about our 2 positive axes. So if I take this and start by drawing a set of axes, and we can see we can go up to 9, so I don't need to go up too far in terms of this line, okay? But something like 10 by 10 is absolutely fine. Label it carefully. Remember, we've done this before. So this one is 0 here, and then you go up in ones and label it on the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is my y-axis. I've gone up to 11 just because I drew the line that big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To go up a little bit further. But this is my x-axis. What that means, okay, is if I go along my x-axis for my x value, okay, and then up my y-axis for my y value. So I'm going to go along to 0, in which case I don't go along at all, and then I go up my y-axis for 1. And that gives me the point 0, 1. Same with the next one, would be 1, 3, I have a point there, and then 2, 5 would be here, 3, 7 would be the next one along, and 4, 9 would be the next one along. What we should find from all of this is when I actually join it all together, is that I have some form of perfectly straight line, right? If you've done this wrong, see how close I can get it. If you've done this wrong, then they won't all match up. If you've done it right, then the point is they should all match up perfectly and form a perfect straight line. Right, that's generally all you're going to be asked in these questions, is to draw something like this. But there's a couple of other little things that I want you to observe. I want you to notice, okay? Right, generally when we're dealing with a straight line, we look for 2 things, okay? So this is the equation y equals 2x plus 1, okay? And when it's in this form, and what I mean by this form is it's in the form y equals something along the lines of y equals ax plus b. So we saw the bit at the start, y equals ax plus b. That was our title, okay? every equation will have a y and an x. So the bits that we change are going to be this a and the b value, and they're important, and they actually tell us something about this line, okay? And there's two things that we look for when we're drawing a line. So the first one is gradient, okay? And that's what we've been looking at, and we're going to tie this in, okay? So I want to know how gradient is relative to this. So if we think about what we're doing in terms of gradient, okay, our gradient is equal to vertical over horizontal, okay? And given that we have a straight line here, we can apply that to this straight line. And what we need to do to be able to do that basically is we need to find, okay, a vertical distance and a horizontal distance. It doesn't matter where we take that. Okay, I'm going to try and start as random as I can. I'm going to start here, okay? And I've got this horizontal distance, and then I've got this vertical distance. Basically what I'm trying to do is kind of almost siphon off a little triangle. And I could have done this anywhere, okay? If I try a different color, and I could try this in a different place. I could have just done this down here, okay? And it would be a slightly different triangle, okay? Slightly bigger triangle, but it still works. And I'm going to come back to that one in a second. I'll start with a pink one just now. So the vertical distance here, if you look, we've got 1, 2, 3, 4. Okay, so our vertical distance is 4 with a horizontal distance of 2. So it becomes 4 divided by 2. 4 divided by 2 is 2. Right, if I'd have done it with a green one, because the point is you're going to do this yourselves and you're going to apply this slightly differently. I've got a vertical distance of 1, 2, 3, 4, 5, 6. So that's this distance here. Okay, so that's a distance of 6. And then a horizontal distance of 1, 2, 3. That's this distance here. Okay, so it would be 6 divided by 3. 6 divided by 3 is exactly the same answer. It's 2. But what we should hopefully spot here is that this number here in our equation is exactly the same as the gradient. Okay, and that applies as long as it's in this form. As long as it's in the form y equals ax plus b. Okay, and what I mean by that is that it's a single y. So we don't want 2y or 3y or half y or anything like that. It needs to be y equals, and then the number basically in front of the x. So however many x's we have is the gradient. Okay, right. What I want you to do throughout this work, okay, a little bit of an extra task for you here, is to work out what this b number means. Okay, so you're going to do a few of these questions, and I want you to try and tell me by the end of this, and you can just write it at the end of your work when you hand this in. I want you to tell me what the b value is in terms of a straight line.